Okay, folks, hello. Welcome to netseminar. Today's speaker is Richard Mortier, who came all the way from the UK, and he brought the rainy weather as well with him. So Richard is a fellow at the University of Nottingham in the Department of Computer Science, and he's a member of the Network Systems Group. His work has been focusing on the intersection of HCI and network systems and the challenges arising when you have to deal with humans besides packets. Before going to University of Nottingham, he was working at Microsoft Research at Cambridge. He got his PhD from the University of Cambridge and his BS as well, and he also spent time here in the Bay in Sprint Labs, and also he founded his own company some time ago. Richard?
Okay, thank you. So, hi, as Yana said, that's where I'm from. As well as being in the School of Computer Science, I work with an interdisciplinary research institute called Horizon, which is what the slides get branded like that. So what I'm going to talk about is a project that we've had going for about 3 years. It's just about come to an end, which has been looking at home networking from kind of the point of view of the user and what we can do to help the user make more sense about it. Starting out, I'm just trying to understand what the users wanted to do. So with quite a strong HCI ethnography element, going through to developing and then deploying some technology and some interfaces to try and see what they make of them. Possibly, I don't need to say all this, but I will anyway, just to make sure everybody's on the same page. So the reason that there's a kind of problem with home networking. Home networking is now kind of mundane. It's sort of expected in large parts of the world that you will have some kind of net access at home. Some of these figures are probably a couple of years old now, so they're probably even greater penetration. At the same time, home networking gear, I think, remains one of the most returned, if not the most returned piece of consumer electronics. Often unopened. I mean, the boxes come back unopened because people can't understand how to make this stuff work. So, although we've got a lot of deployment going on, people have signed up, they're using broadband, a lot of people make some use of it. The software that is around that to help them make use of broadband, help them understand what's going on, help them get their devices connected, and sort of just use the network, is still fairly, it's not as good as it could be, perhaps. So there's still a sort of emphasis in network management, I think, in terms of protocols rather than the activities and the services people carry out. So some of the ethnography data, for example, showed that people don't think anymore of browsing the web. This is not an activity anybody does. People shop, they bank, they do, I don't know, watch videos, watch films and so on. But the net is just another way of delivering that. It's not something they care about particularly. This has all become very mundane. So I think kind of the claim, sort of give away the end of the talk early, the kind of claim we make is that this technology is not quite appropriate for use in this context, or it's not being presented in an appropriate way. It's all the technology that's used, all the protocols that are used, all the way that we manage them, kind of still derives from this idea that you've got an expert sysadmin, a net admin there, to sort of help make sense of this and get things connected, and able to debug things when they don't work and so on. And this is not the case in most households. This is managing the network is a chore. It's another piece of housework that has to be done.
So you mean uninterested, right? Not like impartial, right? Householders.
Yes, I guess neither uninterested nor disinterested is quite the right word, because they are interested in having it work. They want it to work. So uninterested, I guess, I wouldn't quite say that, but they don't want to have to do network management. This is a chore for them. So they are reluctant, the people who do this in most cases. And I think one of the claims we make is that it would be beneficial to enable these kind of top-to-bottom connections to be made so that people could link up what they think of as the network and the activities they try to carry out on the network with what actually is happening down underneath everything, with what the technology is doing. And the keyword that one of the keywords I learned while doing some of this was from the HCI people was it's about making it intelligible, not intelligent. So we don't want the network to be doing things by magic, because then when it does the wrong thing, and it will do eventually, it's impossible to fix. Nobody can understand what's going on. Certainly normal people can't understand what's going on. But if you make it so that they can get a handle on what's happening, so they can control it, then they're much more likely to be able to continue controlling it and to be able to fix it when it doesn't do quite what they expected. So, to sort of set the scene, this is the kind of conception, I think, that was being pushed as what home networking would be like. So it's all quite clean and tidy. There's lots of things connected, and stuff works. And you've got video conferencing at home and delivery of content and all the rest of it. And it's all great. This is the sort of scenario that I guess people have constructed for the homes of the future. I don't know if anybody's home actually looks like that. Certainly, I suspect anybody with children doesn't have a home that looks like that. Very, very tidy. Perhaps this is a more normal sort of experience that people have in their homes with their network configuration. I would guess in a room full of network experts, you wouldn't get that kind of thing with cables everywhere. You certainly wouldn't have cables being like taped to the stairs and things around the house. That clearly never happens. It's all much more like this, where it's all nice and neat and tidy. So this is actually from, there's at least one company that makes bespoke furniture for putting networking gear in for home networks, because people don't like seeing this stuff out on the show. They make cabinets and things, close it away. And this never happens. This is certainly not the case. So there's a kind of thing here about how the reality is quite messy. We tend to try and conceive of these things as being quite tidy and ordered, and in reality they're not. They're messy, and people poke around with them and change them and do all kind of things they shouldn't. In the same way, the sort of the more abstract conceptions of these things. So this is a home network. This actually won a prize from Cisco for the best home network description.
I've seen this diagram. This is great.
So it's a nice diagram. It's a good network. One of the things that was done in this project is we had some ethnographers working with us, and they did some work, and they went to talk to some people. So this was a diagram that one of the households we worked with, I think, produced that described their network. So this was the guy who, I think, I don't even know if it was a guy, this was the person in the household who was kind of the main network admin person. So it's kind of reasonable. They've got cables, and they know USB versus MIDI, and they've got print server and a flat screen and all that. So they've got a pretty good picture of what's going on here. They know about the names of the different machines and so on. I believe it was their partner who produced this diagram of what was going on. So this is much more about physical things in the home: the bed, the desk. You probably can't read them, but some of these comments that are being written about, particularly wireless networking, I think this is crazy energy waves that communicate with the computers, and I think maybe eat our frontal lobe. So there's clearly quite a different conception of what's happening here. It's not a detailed thing in terms of machines and links and so on. This is about things we use in a particular place. And that's kind of it. And then you contrast that with the sort of network engineer perspective, which shows you things like this. These things don't match up. Right? These conceptions of what's going on don't match up. This is kind of the problem. So there's been cases where this was a BBC report from, this is a while ago, 2007, isn't it? This is a while ago. So the state of home networking is pretty dismal, says the Gartner, apparently. And it's the complexity of getting all these things to work together, if you carry on reading down here. So the complexity. So this is a sort of a presentation of information, maybe. We think it's a bit more than that. So these are the kind of interfaces that you get currently on home routers commonly. Right? These are not explaining anything to anybody. Right? I wouldn't have said this one. So this is the sort of the world that people are doing this kind of thing. This is where home networks seem to be. Right? So what did we do then in the project to try and start to address this? So we did some ethnographic studies. When we say we, I don't mean I didn't do this. The project did this. Other people in the project did this. So we did ethnographic studies of about 24 homes. So we went in, the ethnographers went in, they did technology tours, they got people to talk through what was in their homes. Did some semi-structured interviews, they got kind of anecdotes and war stories, and just finding out what people try and do in a fairly rich sense. So the idea here is not to be sort of statistically sampling the population. This is just to get some idea of the kind of richness and detail that's available here around how people use and manage their home networks. So the sort of things that they found as part of sort of coming out of this. So in people's homes, in home networks nowadays, there's a very heterogeneous collection of devices. Sort of 5 to 15 devices seem to be the rough kind of range of things people are connecting. UK average that's claimed is about 4.6. So it's kind of within scope, but probably a bit bigger. There's lots and lots of different things being connected. These are not computers. Right? It's not laptops and desktops connected to the network now. This is all kind of devices around the home. Ownership and access rights are really very fluid. It's not simple enough to say, that's Dad's computer, that's the boy's laptop, and that's it. Okay? These things are passed around, they change who's allowed to use them at different points in time based on where you are and who's there and all this kind of stuff. And again, this fact that the digital housework is one of these unremarkable things now. Somebody in the house just has to do it and make sure everything's still working, and when the router goes down, they go and give it a kick to make sure to try and get it back online, and this kind of thing. So, what sort of came out of this? So I guess what came out of this was we picked up various themes from these kind of interviews, and there were sort of 4 kind of challenges that were around consumption, so trying to understand bandwidth use in the home. Monitoring, so trying to see what the performance of the network was and see what was going on right now. Being able to prioritise network activities, this turns out to be something that people seem to want to do. And being able to police the network and police activities on the network. And it's kind of important there is policing activities, not network level behaviour. So the sort of, to give you some snippets, some examples of this. So commentary from, picked up the first point there. So they want to see, this particular household wants to see, or this person in this household wants to see a historical record of bandwidth use. So the context of this was that they had just got a lodger, and the lodger was causing them to exceed their monthly bandwidth cap. And the belief was that this was because the lodger was doing a lot of, accessing a lot of video from the Far East, because that's where the lodger came from. But they didn't have any evidence to present them that and say, look, can you start contributing a bit every month to this, because we're not able to use the network now. So the second point, monitoring. So there were a couple of households where some of the kids, for example, do a lot of bit torrenting, and this was getting in the way of other activities. And again, it's this thing of being able to just see what was going on, so that the household, people in the household that had time, could then kind of negotiate what was supposed to happen there, rather than being able to say up front, we never want to see BitTorrent on this network. Right, it's not such a black and white decision. It's all to do with what's going on right now, what time of day it is, what day of the week it is, what are other people trying to do. The prioritisation. So this came up in a couple of cases where people would work from home. And so there was definitely this quite strong opinion that if you were working from home, then you got priority on the network because you were working and bringing in the money to pay for the network, essentially. So the kids could get out of the way while you were doing stuff. It wasn't that you wanted to stop them doing what they were doing, but you just now wanted your activity to get delayed or paused for any reason.
Maybe they're the ones doing the work and bringing in the income.
Well, nowadays this is maybe more likely true. There was I mean, this kind of goes back to the conception of activities on network as well. So there was one case where the family kind of had this policy where if the dad was online doing his banking activity, got online to his bank, everybody else had to stop using the network because he didn't want anything to get in the way and kind of affect that. So for him, this was because banking is an important activity, right? You don't want that to be affected by other activities. And then the final thing was policing. So this was policing activity, again, not in a way of saying you must not do this ever, but in this much more kind of negotiated, nuanced way, to use the word the ethnologist used. So in this case it was student, I think in this case it was student had to do homework, exams were coming up, and she was spending too much time on Facebook. So there was a negotiation that had to go on about getting on Facebook or not. Was it the appropriate time to go on Facebook? Have you finished your homework? Then you can go on Facebook, kind of thing.
That's my house.
If you'd like to take part.
I tell you, there's a fortune to be made. There is no good tool available that allows you to solve that problem. And there must be tens of millions of people I mean, it's
so
Facebook has been resisting having anyone solve it.
I'll attempt to come back to that later.
Yeah, good.
So another example here, which is quite interesting, was the parent did not want to ask another parent for the password to the other parent's wireless network to give to her child when her child went out to visit, because the other parent's partner worked from home and they didn't want their child doing things they shouldn't do on the network or is somehow getting in the way. So she was actually going to buy a 3G dongle for her child so that when her child went to visit his friend, he could get on the network using the 3G dongle rather than trying to get access to the wireless network in the home. Because that was going to be too difficult a social situation to deal with. So these things are quite, as I say, quite subtle in some ways. So what do we do to address this? Talk a lot faster than I expected. So we built a thing that we could try and deploy to get some idea of what we could do to affect these things. So we looked basically at the home router as being the gateway point. One of the criteria was we didn't want to have to go around and change any of the devices that were connecting. So really all the stuff we did was going to be in the home router. So we misspelled infrastructure. So we built some software that sat on an EE-PC for ease of use to start with, running all the standard Linux host ABD kind of stack, and built some APIs against that using OpenFlow and a custom pub subsystem, which a partner at Glasgow built. There's an excuse, I think, for the head of school there to do some coding while he was having to be head of school. And so we then used OpenFlow and Nox as the kind of control interface to that, because it seemed to be both a reasonably straightforward way of getting at that control. Flow level management of this seemed to make sense, and it also left open the possibility in the future that you could imagine a kind of three-way negotiation or two-way negotiation going on here between the ISP and the home, the people in the home, about how they wanted their network to be controlled and what was the appropriate thing to happen right now. And a policy management engine for managing policy. I'll probably come back to towards the end. So the obligatory system diagram for this. So this was how the software was constructed. So the database sits at the top, HWDB, and that provides all the monitoring capability, and that feeds into Nox and the policy engine. And then we've got a control API, DHCP implementation, a DNS interceptor. This kind of gave us the control we could exercise then over how the network was being used. There's a simple web API against this. So based on those challenges that we kind of brought out from the themes of what people were talking about when they were interviewed for this, it was really sort of levels of control. Ideally, these control would be based on users and activities. That was a step that we haven't managed to take yet. So in fact, we're basing it all on devices as an approximation to that. I have a PhD student currently who started to analyse some of the log data from this to see if we can work out ways of automatically inferring the network layer, what the activities are, and particularly who the users are that are doing them, whether there's any sort of signal you can pull out there. And this, I think, possibly differently to the way that a lot of HCI takes place, this was building a technology platform on which lots of different interfaces could be explored, rather than going in and doing the kind of the minimal, let's try this interface thing out, and just sticking with one thing. So this was something that was an interesting interaction within the project, because a lot of the HCI people were kind of going, come on, like 2 weeks, 3 weeks, we need a prototype out there, we want to get in there fast and see whether this works or not. And we were kind of saying, no, this is the home router, it really does have to work, because the first time the internet breaks after we put this thing in, they're going to throw it out the window and turn the old stuff back on again, and they'll never talk to us again. So there was kind of a timescale issue doing the research there, which was quite interesting, and took some working through. So this was the context. So we got the router there, presents this API, and then we set up a bunch of different interfaces on tablets and smartphones and other things around the house. So I tend to talk quite fast, by the way, so if there are questions, please stop. Otherwise I'll just get faster. I'll talk through some of the interfaces, some of the things we built and tested to different degrees with the households involved. So the first one was sort of measurement and interaction. So these were fairly simplistic interfaces on iPod touches. These were deployed as. So this was the database, the HWDB database, capturing traffic in real time, and you can post user actions into that as well from the different control interfaces. And then there's a notification service that you could use to allow users to be informed about what was happening. So you could set the notification service to say, tweet the following accounts, or do a push notification, whatever, to say that something's happened or some trigger's been exceeded. So this kind of thing was pretty useful for some of the households, because they could now start to see what was happening. So just a kind of instantaneous thing of being able to say, why is the network slow now? Look at the thing, oh, Tom's laptop is going mental through BitTorrent or something. And this kind of, it scratched that itch for them anyway. Obviously there are weaknesses here, significant weaknesses, particularly being things like this. This is just a protocol level, port-based naming of traffic, which is not really very meaningful to anybody. And possibly not correct, I think. So, but it did enough to give people a feel for it, at least to start with. It's clearly better that we could do that. An interesting feature of doing things in the home is that there's quite a lot of physical access control around your home, usually. It's either a tent or something. So this kind of physical access and physical devices, physical interfaces are kind of the norm here. So this was I tend to call it the network commode, which is not perhaps a very good name. Basically it's a thing about this big with a bunch of LEDs and an Arduino in it, and it would interface to the APIs on the router and was then able to display things like signal strength at the point this device was sitting in the house currently. It could also show you DHCP leases being acquired, so devices coming on and off the network essentially. So you could kind of, the idea was that this was going to be a thing of interest on the coffee table that you could sort of glance at and get a feel for what was going on without needing to be too engaged with the detail of it. And if you were finding that, for example, signal strength was too variable, or you weren't getting good connection in your bedroom or something, you could take this upstairs and sit it down, put it in the right mode, and have a look and see what you were getting, what was happening. There's an interesting thing about that. You might think that if you didn't get wireless coverage into certain rooms in the house, that would be considered a problem in most households. You don't get signal up in the kids' bedrooms, this is an issue. So at least one household where they said, we don't get wireless connectivity going into the children's bedrooms. And this is a great thing, we love it, because it means they can't go online in their bedrooms without us being able to see what's going on and see what they're actually doing. So it's always clear that increasing coverage is a good thing. The other thing we did, and it was a sort of physical thing which I don't have a photo of, is using USB keys as a way of controlling access. So we used the USB, what's it called? UDEV interface on the Linux. So we could have a USB key being plugged in with certain files in the root file system on that, and that would permit certain devices to be connected, or could permit certain devices to do certain DNS resolutions, for example. So this was one way we thought of addressing this. Kids can't do Facebook until they finish their homework. The idea would be that mother would have the USB key, and until that key was plugged in, Facebook was not available for the devices of the children. And this kind of interaction between these physical control interfaces and then this virtual thing was sort of interesting. We didn't actually deploy that one for the test though. But anyway, there's a bunch of things you can do physically which make sense in this context. I'll go into a bit more detail now with the physical markers, one here for security. So this was a way that we were trying to address the problem of association. So getting devices associated to a home network is one of the key pain points that people seem to have, particularly when these are not devices with keyboards. So getting a game console or a TV connected where you've got like a one-dimensional interface and you've got to scroll through a full alphanumeric thing to try and input a 20-character passphrase or something, it's really kind of annoying, quite time-consuming and fiddly, and people get it wrong. So we're kind of wondering what we could do about that. So the way we tried to address that was just to kind of invert the problem. So instead of trying to get the credentials from the network into every client device to connect, we put the credentials for the client device onto the client device in the form of the QR code. And then we can have a controller which has previously been securely associated, scan the QR code and instruct the router to create a virtual access point with the correct credentials for that device. So we've got the router supporting essentially a virtual access point per device, and then when the device is on, it just automatically connects. It's already got the credentials pre-installed. The idea would be that would be done at manufacture time, or you take it along to Good Guys or something and say, please give this a thing so that it can get on the network, and print out the QR code and I'll stick it on the outside. So that's the kind of the sort of interaction there. We did some usability trials of this, a usability study. So the test condition was that users were asked to construct a network with these three devices, so a HP printer, squeeze box and laptop, and compare that to using WPS Direct. Sort of how usable did they find this? In order to make this fair comparison, we rewrote the instructions in both cases to try and make the instructions for what they had to do roughly comparable. This was particularly important with the printer. The PhD student who ran this test also works as a sysadmin for the university, and I think it took him somewhere between 20 and 40 minutes to get the printer connected the first time around he tried it, with the instruction booklet in front of him. It was like 17 clicks down through the menu system on the printer control panel to get to the point where you could push the button for WPS. It was kind of non-trivial. So we ran a bunch of people through this. 10 with a home network admin of the 16, 12 that never used WPS, 6 that never used QR codes. And the home networks that these people had, again, were in that kind of range of, in this case, 3 to 15, but the sort of reasonable sized networks. So when they ran through this test to see how long it took them to get these devices on the network, the configuration times were fairly convincing. So with WPS, a couple of minutes in the case of the printer usually following these instructions, not much less in the case of the squeeze box. With the multi-net system, just scanning this QR code, it was relatively straightforward. They tended to get things on the network much faster. The other thing that was a nice side effect of this is because the interaction remains the same between each of the devices, instead of having to go and learn a new menu system and click through a different thing every time, it's the same. You scan the QR code, the devices on the network. And so people stopped having to read the instructions much more quickly as they went through this test. That's the flavour of the user study we did there. The other things that we've done have been tested through more long-term deployment with users. So another kind of thing we tried, another intervention we tried, was to get people into the protocols a bit more. So rather than trying to set things up so they happen automatically, as you might in an enterprise network where you've got a certain scale deployment you want to manage, you try and simplify things. You've got a few experts to run it for tens or hundreds of thousands of people. These are much smaller networks, and a lot of the decisions that are to be taken are harder to encode in a database or some other kind of back-end system. So we amended the DHCP server, when we wrote the DHCP server that sat inside Knox, so that it would, rather than just saying yes when somebody requests an address, it pops up on, in this case, an HTML5 interface, running on a tablet, I think this one was, when we deployed it, with the device as requesting permission. So the middle column is where the device that's currently trying to send a DHCP request ends up sitting. And then if you want to put that device on the network, you just drag it across to the permitted column. If you want to take it off the network or deny it, you drag it over to the denied, not allowed column. And this gives you quite a nice sort of interaction point where you can also get a bit of metadata about the device as well. So you can get the person who's permitting it or denying it, or in particular permitting it, to give you some information about it. So what's its name, who owns it, that kind of thing, which kind of helps with some of the other things then that you might want to build around this. And then you can put this as a situated display, so anybody walking past is allowed to do or is able to do this. And that probably makes sense in a house because you know, if they've got in through the front door, then they're sort of trusted to some extent, so they kind of get this degree of control. This one also seemed to go down fairly well with people. So part of the thing that they liked was just that they could see what was around them, and they could see how many devices there were. All this world that was previously unknown to them, they could now see something. And we took this as a demo for SIGCOM a couple of years ago. We were surprised to see there were like 3,000 devices or something visible there in the hotel. So that was a surprise for us, certainly. They could also see how to get people off the network, which was something that it turns out a number of the households wanted to do. So they'd have guests come round, the children would have friends come round. They'd want to have network access while they were in the house. But the parents weren't entirely happy with the idea of leaving them on the network, sort of forevermore, as it were. So the ability to have them on when the kids were visiting, then take them off as they left, was something, kind of a facility they quite like the idea of. At the same time, they didn't always want to have to do that. So this kind of, again, just giving people back this degree of control so they can make the decision as to whether devices are always going to be permitted onto the network in the future, or whether this device is only on for the next couple of hours and then the kid's going to go home and take them off. It's about giving the control back to the individual. The final sort of control interface then was with the DNS intervention, the DNS server interceptor. So this was another way of trying to police access to different services on the network. So this was a DNS interceptor proxy that sat in the middle in the router and would deny resolution of certain names based on various information, such as a calendar. So you could say, you can set sort of times when the kids were allowed to get on Facebook, for example. And you can say, well, they're allowed to do it the weekend, and they're allowed to do it for an hour in the evenings, but they're not allowed to do it for the rest of the day, or whatever it might be. As kids' access to Facebook seems to be a common driver for some of this stuff. And again, using some of the other infrastructure, it wasn't just about denying it. I'll get onto that in a moment with the policy stuff, but it wasn't just about denying access, it was also about recording or notifying of access. So that's sometimes more useful than simply saying yes or no automatically. Again, coming back to this intelligible versus intelligent point. So the final interface I'll talk about then is the policy interface we constructed. So this was kind of how to set things up so you could give information to users so they could control the network. From the interface side of this was about being deliberately non-technical and playful with the interface, so it wasn't going to be a standard kind of policy-based thing. And the idea was to exploit sequential art or comics as a way of setting things up, which you could then personalise for individual families. So this was the kind of interface we ended up with. So this is a policy interface. The idea would be that this was implemented on an iPad. You'd have a bunch of these comics that would kind of contain the policies you have for your network, for your home network. So this particular one, you can flip through each of these panels. So you can say when mum is, when dad is, when the kids are, etc. On the computer, the laptop, the phone. In this case, it's being used between particular time ranges. You can also set it so as once it's achieved once it's used a certain amount of bandwidth, and when it's being used on certain days, when it's accessing certain sites, then you can take an action, and the action can be to block a particular device, which need not be the device that's being monitored. The action might be to notify an individual through a particular channel. So there are different things you can set up with this. So it's a way of presenting event condition action policies to people who really don't think in those terms normally, and are not usually interested in this kind of thing. This may seem like, why would you ever use that? But it turns out we've had in 2 of the deployed households, it's been used a total of 3 times to set up rules, set up policies on the network. And it was the children accessing Facebook example that was set. So in one household, it was set to block the computer. So this thing was actually done. So if the daughter's computer accessed Facebook, then that computer would be denied access to the network completely, which would then lead to the daughter having to get hold of the parents to say, yeah, I don't know what was going on there. I guess something must have happened. Please, could you put me back on the network? I need to finish my homework. So it was kind of used as a trigger for negotiation, even though that was a fairly firm trigger, I guess. I think one of the other houses, it was used, the notification service was used in a similar kind of way, where instead of denying access, it was just mum was going to get a direct message or SMS or something when certain actions happen on the network. So it turns out that if you give people the tools here that they can kind of understand to some extent, they do sometimes start to try and use them. I mean, some of the other feedback we got from one of the other deployed households was, yeah, this is not for us. This is I think one of the student households this was in, so it was a shared house. They didn't feel comfortable doing this because it would mean that somebody was setting the policy, so somebody was kind of taking a in charge role here, and that wasn't appropriate for them. So they were much more about some of the ad hoc, using some of the ad hoc interfaces where you could make decisions on a much more kind of live time scale. So they're not appropriate everywhere, but it turned out this did work quite well in a couple of cases. Right. What I'm going to do now is kind of, for completeness, I'll point to some of the theoretical work that went on within the project. This was not work I did. Don't ask me any hard questions. I can point you to the people who did it if you're interested. So one of the things that was addressed within this as well was how can we try and automatically reason about some of the state going on here and make decisions to help the household to understand when things have gone wrong, when things aren't being done the way they expect. So the approach that was taken by a couple of people in Glasgow was to take a modelling approach from Robbie Milner called bigraphs and try and apply this to model the home network, the state of the home network. So bigraphs, basically you can look at spatial and temporal relationships simultaneously. So you can look at representing locality and connectivity within this. And then one of the neat things about them is you've got visual and algebraic representations which are entirely equivalent. So you can reason about these automatically using the algebraic representation, but you can also automatically generate and present displays of what the state of the network is currently to the user. So the kind of flow that was implemented here was that you've got events coming in, or traffic coming into the network, turning into events, which get fed into this thing which encodes it into a bigraph, analyses it, and then can both feedback to the network to make some control decisions to say, for example, this device has joined the network, this policy needs to be applied to it, it's not been applied yet. And you can also log things and basically show to the user, this is what's happened, this is a display of what's occurred here. That's kind of what I just described, I guess. So one of the nice things here is this interplay between the policies that are being applied and kind of real-time events that are occurring as the network is in use. So you can interpret policies as properties the system has to satisfy. And then when events invalidate this, so you start out with a policy applying a state that says all machines are blocked, then you add a machine, that machine is not blocked at that point, and so it needs to become blocked. So the bigraph analysis can tell you that this state has occurred, this is the following thing that needs to happen. And they implement a prototype of this, and it turns out, because of this, again, because of the size of this kind of network and the scope of this kind of problem, you can actually do this reasonably quickly. So this kind of thing could be running live in the background and keeping an up-to-date picture of which policies have been applied, which ones haven't, what was in violation, what the state of the system was. This is a sort of example of the automatic visualization that you get from this. So that's a visual representation of Y-graph, which represents that state, where you've got a router and a machine, both have wireless connectivity to each other. And that is completely equivalent to the algebraic representation that's in use inside the code. So, just to kind of summarize the deployments that we did and the results we got from those deployments. So, the deployments we did for the router and interfaces were fairly long, in fact, in comparison to a number of these studies. A number of other studies in this area. So they were in the households for something like 4 to 6 months, depending on which house it was. So the initial thing about some of the traffic displays was you get this same effect you get with home energy displays. I don't know what the status is here in the US, but in Europe this is quite an active topic of home energy monitoring, consumption monitoring. You get a novelty effect. So when it first goes in, people are looking at it all the time. Like every 10 minutes or something, they want to see what the network's doing for about the first week or two. And after that, it goes in the cupboard, nobody cares. Maybe until there's a particular reason to get it out. So the case of that module, for example, that would give you a reason for wanting to know that again. But it's not something you really care about enough to keep doing. One of the things that we did see, though, was that when you surface what's going on to people and start to expose the network to them, you get what they refer to as domestic discord. So it turns out that, again, this thing about the network being quite mundane, something that's just part of everyday life, means that it gets intertwined with the way things are in the home anyway, so the sort of relationships people have with each other and what they're trying to do, and the network is just another thing that they use in day-to-day life. So when you start showing people how it's being used, and when it's being used, and for what it's being used, this can lead to people basically arguing about what it should be being used for, what it's not being used for, who's getting in my way for it. And it turns out this can get quite intense in some households. There was another interesting angle that came out of this, which was that privacy starts to be an issue even within the household. So one of the things we can obviously do with a home router is you can record a lot of information about how the network's being used, potentially, certainly what's using it, potentially who's using it. This kind of thing is already happening in many houses. So it was, I think, at least a few cases, the relationship between the parents and the children was would have the parents saying, well, you know, I want to know what you've been doing. I'm going to come and look at your browser history. I want to know what you've been accessing over the last week, and this was a normal thing, a reasonable thing. If you move the recording into the router, it completely changes that relationship. One of the things you do when you go and ask to look at the browser history is you have to go and ask the person involved to get access to that device, because the history is on the device. When you put it centrally on the router, you can now do it surreptitiously if you were to choose to do that. And so the access to that and how you allow that relationship to, allow that activity to happen becomes quite subtle, because you have to kind of have trust still happening within the house, right? People still have to trust each other, they're not being snooped on. And so managing that becomes quite an interesting problem, which we've not solved yet, unfortunately. And it all comes back to this thing of, when you're managing a network inside a home network inside a house, it's part of managing the household, it's part of what happens anyway, that people have certain roles in the house, they do certain things. And it turns out that people in the household want to have some control over this, they want to have some involvement in this, because it is just part of what they do, part of living their lives. So to sum up, home networks have become mundane. They're just another way that everyday life happens. There's a sort of, I guess the business incentive, the economic incentive here, is that there's more and more things that are being predicated on the idea that home networking exists and people can get connected all the time, they can do more and more things online. There's something in the UK that's coming along in the next year or so So I think the government is moving to what's called digital by default. So a lot of the benefit system is going to be online by default. You're going to get access to social security and things like that online. It's no longer going to be pieces of paper being delivered, or at least it's going to be much fewer pieces of paper being delivered to people's houses. And so there's a real kind of need for people to get online to make use of this. Certainly not a need, very strong incentive for them to get online. And these things still just don't work that well in many cases. They don't provide the right degrees of control in the right places. So it turns out that it is about making the network intelligent. It's about allowing people to understand and control this rather than trying to hide it away and make it all automatic for them. So this, some of the sort of phrases that seem to describe this, things like getting interaction into the infrastructure, so you can actually have people controlling it and using it in the way they want it to work. And this is not something that the HCI community really seems to do very much of. So they tend to focus more on the interactions themselves, not so much on how you will change the infrastructure to permit different interactions or make different interactions possible. So it's stuff like, when we monitor traffic, it still tends to be these kind of levels. You're monitoring protocols, you're monitoring particular services, you're not monitoring activities that are taking place above that. There's not the vocabulary that you make available to people who are designing interfaces to deal with. And then the sort of final slide, I guess, was some of the interesting things I think that I certainly experienced coming out of this, was that this wasn't something that could have happened just from within a networking systems group. It really did need this kind of all these different angles to be brought to bear on it. And explaining to ethnographers about what you can and can't do in the home router from a technical point of view was an interesting experience. And having to learn some of this vocabulary like affordance and things, some of the HCI terms that I came into contact with for the first time, was a sort of interesting thing in the reverse sense. And I think this is going to become increasingly important as technology gets deployed out to people who really don't want to be expert and yet still want to use it. I think it's obviously already important, and it's going to become more so. And I'll finish there. Any questions?
Can you go back to the previous slide? So I'm surprised because I would think machine learning would be one of the first to go up here, right after HCI, in the sense that if you're trying to present someone an understandable description of what's going on so they can manage bandwidth, so it's shopping versus HTTP, that you would want to build a giant model of what is that traffic, or use all the features you have, like what was the DNS resolution, maybe the IP itself includes some information, the amount of traffic, the time you've been doing it, all those things can contribute to a much more understandable a model of what someone is doing, so that if you're managing the network, you go, okay, this is shopping, this is downloading, let me separate the two.
So I think at some level, yes. It wasn't something we did within this project, although I have a student who now started to take some of the logs that we've collected here and begin to do some analysis to try and figure out what the features are and what tools like from machine learning can be applied to do some of that. As I understand it from colleagues who work in this, it might be the case that machine learning is not actually the right way to go in terms of certain techniques, because they tend, as I understand it, those techniques tend to produce quite black box sort of results. So you get a model that works quite well, but you don't really get any indication of how it's working or what it's using to do that. And so somebody I work with who's quite into fuzzy logic thinks that that kind of angle of computational intelligence might be more appropriate, because you get more explainability of what's happened and why those decisions were taken. But yes, it's clear that there's a big gap between the raw data you can collect and the kind of the inputs you need to make decisions based on that. And yeah, some kind of processing like that is going to take place in the middle, I think.
So, given that children are usually much better than adults at opening child-proof, models, locks, etc., is the idea of Facebook, blocking Facebook, even a sane or possible idea?
Sort of. So, on the one hand, people will have 3D access on their smartphone, their tablet.
Well, that's the other thing. Is home networking even relevant if everybody has smartphones? I mean, it's another question, I guess.
But again, it's about putting controls where they can be used within the house. So it might not be so much that you want to stop this access, and it's a binary, if they get access, would fail situation. It's just you want to have a way of really enforcing the idea that it's important they don't do it now, and that homework is important and should be done. So you've got to make it easy for them to access, or if they try and do it the easy way, at least you get told. So this is what happened in these cases, was that it wasn't so much that it was the blocking that was important, it was that the action took place, and that caused a negotiation to happen. It caused the parents to have the conversation with the child about how important homework was.
So they might back off and say, oh, well, okay, maybe I won't do Facebook, or maybe I won't do it while Dad's doing his banking transaction.
Yeah, well, that kind of thing. So you know, maybe I won't do it until maybe these exams really do matter, right? I am going to do some revision now. And so it wasn't this case. It's not like, as I said, it's kind of not like doing network management in larger networks where if it fails, and that's really bad. It was just this thing of trying to service it and make people aware of it so that they could sort it out for themselves.
Let's try line to see how much difference there is between, say, the small business market for internet access networking versus the home. It's just the same.
Yeah. I don't know. I think one of we went into the domestic network because that was where a bunch of previous work had already taken place. Within Nottingham, certainly. I think it would be very interesting to apply this in small businesses, kind of small office scenario, guest houses, that kind of situation. I think they would also be potentially good customers for some of this sort of approach.
So, at the start of the talk, I was actually thinking that one of the things that you might get into is trying to figure out how to correlate the low-level networking information with the activities. For example, a kid accessing Facebook. Can you actually know that the kid actually accesses Facebook? Right, because he has to be logged in, there should be some way of figuring out that that password should be sent to Facebook somehow. But it does seem like that is an intrinsically difficult problem because everything goes through CDN these days. It's like IP address tells you nothing. So there's a lot to be done there. I'm wondering if you guys took a poke at it or not.
So what we did try there was the DNS thing. So it's a combination of DNS and URL monitoring. Maybe gives you some of that. So the DNS proxy that we have there basically doesn't permit anything through unless it's seen a resolution for that IP address. So it gets someone who it is, so it doesn't reverse resolution piece. So it's never seen, otherwise it intercepts the DNS request, matches up the response that comes back, and then makes a decision as to whether that flow is going to be inserted or not. And that probably gets you some of the way there. It's not quite as easy as that because there are cases like where you've got virtual web server stuff. So news.bbc.co.uk is remapped to www.bbc.co.uk/news, and you've got to catch quite a lot of different names there to actually prevent access to that service if that's what you want to do. But that seems to be the most promising way we can do so far.
How do you distinguish between accessing some site like Twitter versus every site on the web that has a Twitter button, and every time I load a web page, it loads about 60 other social networking, Facebook, Twitter, Google+1, etc. How do you distinguish that, or is that even possible?
So well,
I guess it's URL matching, but it's pretty hard probably because they're constantly updating it.
Yeah, so that'll be a combination of URL matching and the resolution that occurs when the object in the page is fetched. At the moment, probably the experience that's delivered to the user if we do that sucks a certain amount because they're going to get lots of crosses on the page where stuff couldn't be loaded. So doing something better there would be better. We haven't gone that far down that route yet.
So one of the use cases you talked about is this kid who goes to his friend's house and he's not allowed access to the internet because mom is. So ideally, some of the policies that the parent has installed for that kid should follow when he goes to that. So have you had any thoughts about how that can be done?
So we've started looking at how you could integrate this with mobility and kind of have a home access point within the policy thing. We haven't implemented or deployed any of that yet. But yes, I think there is, and particularly if we could figure out a way of taking that and then applying it to the devices near the networks that are not home wireless networks, but are things like devices on the phone, that would completely be interesting. That would almost certainly require some kind of ISP involvement or software client involvement.
So most of the use cases that you've shown, they assume like a static model where the user has to understand what happens, and then based on this knowledge, he can configure some policies for his network. Right? Have you looked at and you said that the user knows the context that the network behaves. Have you looked at things that the user just said something goes wrong, or I have a problem in my network now, and then you're trying to infer from the current context
How's it going on?
So, at least in one version of the router we deployed, there was a kind of, if you hit this button, when things have gone wrong, and there's going to be a log of the last couple of hours or something, which will then get dumped for the principals to look at. Basically, it didn't get used, so we didn't get data out of it. But that would be a thing that's interesting. I think some of that sort of facility would be interesting in the context of some of the line graph things, because that gives you this running picture of what's happening. So you have a more abstract model than having to dump a couple of hundred megs of log and then go and analyze it. You've got this kind of running model of what the state is. And then for you to say the state is bad at the moment, you could then do inference on that. Apply machine learning or something and try and figure out what was indicated when they kept saying things have gone wrong. We haven't done.
It seems to me that there's two types of things that you're trying to control. One of them are sort of plumbing related. Who can use this shared link? Right? Who is it that had permission to use the shared link? And then there's the social engineering part, which is I don't want my kid doing blah. Right? They're sort of two categories. And it seems as though it's ultimately it's the right place to solve the first problem because you're sitting in the path of this shared link. But the second one, it seems that it's a losing proposition because with the number of 3G connected or 4G connected devices in a home, or the ability to connect to next door neighbor, or the ability to just walk down the street and use the coffee shop, or if you're actually particularly interested in the prevention of particular activities, whether it's kids or any type of activity, or I don't want someone accessing the bank from this particular device because it's not secure, or it's an iPad that might get stolen. It would seem as though that's a function of the device. That's a property that you want of the device. That's something that you want as a there are fairly rudimentary things that do this kind of thing already on different, particularly mobile devices and laptop devices. It just seems like that's where it belongs, because it belongs closer to the application. You know who the user is, you know what the things are that they're doing. It seems as though this can't continue to sit. So even if you figure out how to place it in this home device through which all of the traffic is going, as soon as a large fraction of that traffic isn't going through that, then it becomes impractical to do.
I think.
And the semi-sophisticated teenager can always create a proxy or a tunnel, or right.
Well, yeah. I mean,
and so it's fairly easily got around. But if it's something that you've denied essentially at the application level of the device or the MP, it's probably breakable, but it's where it belongs. Right?
I think that's. So I think that it is certainly arguable that a lot of the application level stuff should be done in the application, because that's really where you've got the context. If you want to do it automatically, and if you need to have it work, one of the things that I kind of realised doing this was that a lot of the time it's not the case that if somebody gets around it, the threat model is not that you want to stop people, and that's it. And if they get through, you've failed.
Right.
The whole thing's broken.
Right.
It's that you need to kind of make that information available, or give people a kind of impetus to think about this, or to talk about it, or to negotiate it, whatever. So it's not the case that if the semi-sophisticated teenager puts a tunnel through and VPNs out or something, that the whole thing is broken. It's in the same way that if you ground somebody and they manage to get out for the night, it's not the end of the world, right? But this does mean when you find out that's happened, you're going to have a fairly serious conversation with them about their behaviour. And so it's more that kind of thing. So it's more about getting some of this information into the normal processes that people have in their families at home. So I think it's thinking that it's if somebody gets around some of these mechanisms, it's broken. Is not the right way to think about it.
So I still argue that anything that's to do with the application belongs at the end device, right? It's going to be an easier interface. Now there is no current way to farm or collect that information, so it's either settable centrally or measurable centrally, or made visible in a central location. However, I would love to have a simple, or love to see a simple to understand way of representing how much of my home network is carrying Netflix as opposed to Dropbox, right?
Right.
So why 90% of the problems are probably caused by simple things like that. But they're likely to be performance related. So this seems to be largely to do with access control. It just seems like a funny, the wrong place to put the access control. And in that particular location, I care about why doesn't my network work? And having sort of more indications of, well, it doesn't work because of these particular colliding applications, or you're doing too much stuff, or you've got 3 people watching
Yeah,
videos.
so I certainly, I don't think.
And that's all,
If I get this
all
impression-
present there, right? That's all present at that point. It has to be because that's that particular network that's broken.
Yeah, so I think, what do I think about this? If I've given the impression that this is the final solution, then
Yeah.
that's the wrong
Uh-huh.
impression. I didn't
Yeah.
mean to give that impression. I think it's part of the solution though. I think having some of the stuff in the router does make sense, because there are, at the moment, some of the channels for delivering, for example, applications that could do monitoring and control to a lot of these devices are just not good channels, right? It's too hard to install new software on your TV. But there are certainly cases where that completely makes sense. So the idea that you try and get this thing installed on your kids' smartphones, for example, that there'd be something running on there that would give you the information, that would be a condition of them having a phone.
Right.
That would completely make sense.
Uh-huh.
And hopefully that would be able to be done in such a way that it would feed into this sort of infrastructure, so there's a certain collaboration that could occur there between these different devices, different monitoring points. This seemed like a good place to start, particularly given the state of the art at the moment in terms of where's the best place to get enough coverage to start doing some of this, and that seems to be in the router, rather than trying to go after individual things and applications. There are definitely things you can do with sort of Chrome plugins and browser plugins and things like this that will get you a lot of the way there for some of those applications, some of those specific applications.
So you had a really good kind of. I thought the pictures that people have drawn in the network were really fantastic. That's sort of the state before, and you mentioned that you want to make the sort of change people's mental model of the network. And so I wonder what's the after picture look like, or how did you change people's perception of the network, or what pictures would they draw now? Do you have any results from that?
Unfortunately, no, I don't. It would be interesting to see what people kind of learn by having seen the service. We don't have that.
Great question.
So,
You want them actually saying, there's a network? Right. I don't have a network, do I? Right, it's actually one of the response, right? Oh,
Yeah,
I
no,
don't
it's,
even know it's that.
yeah, the richness of the way different people can see some of this stuff is.
Yeah, but it's all the intelligibility, like how are people, and how has their mental model changed now that they have the system?
Yeah.
Great to know.
So have you talked to any ISPs if they're willing to take over this kind of management, and how enthusiastic are they about
So
for users?
Partners on the 2 commercial partners on the project were Microsoft Research Cambridge and BT. So BT is the UK national ISP, essentially. So they provide, they're the wholesaler for all the DSL connectivity, I think, in the UK. They're very interested in some of this stuff from a point of view of support call costs. Essentially, they would very much like to have things in people's homes that allow them to reduce support call costs, because that's a significant cost for them. And having some of this information available, being able to have their people do not even necessarily diagnosis, but just see what's going on, so they don't get that call and they just go, oh, stop a bit, horrible, oh, the network's just busy at the moment, will be a benefit to them. So we've tried to talk to them about how we can go about getting some of this stuff deployed or commercialised or whatever. But it's one of the problems there seems to be that the sort of cost structures there don't really permit this so easily, because the division that makes the home hub is focused on reducing costs in that, and then if other divisions want to have more stuff in there to reduce their costs, 100 people home, but this will cost us more. So there's a sort of, it seems like there's this continual argument I don't really have any information about, and I'd like to get information about it if I could, as to whether the home router should be really thin and all the stuff offloaded, or the functionality offloaded, or whether the home router should be fairly fat and able to do stuff and retrieve information, give measurements back, and like what actually is the best place to put that functionality in order to reduce cost overall. We'd like to follow up with some of that, but we've not managed to get into it yet.
My guess would be that in 10 or 15 years, that device that you have in the home would look more like a Meraki device, which is essentially a dumb access point with in this case an uplink to a very a reliable uplink. In other words, the high degree of connectivity, and then everything else done from the cloud. was the entire management control of almost everything that's going on within the home. I think that ultimately the home user just does not want to know the stuff. They want to be able to, you know, the way that you have the control here, they want to be able to do that through a web browser. And they obviously don't care where that's actually sitting.
So,
and then allow for, you know, more upgradability, more you know, improvement of an upgrade of that service over time. Just have it completely outsourced. I would imagine that would be the way that it would go.
I discussed this before lunch with Yanis, in fact.
Yeah.
So I think that I don't really have a strong view on where that functionality goes, but I think that some of the things it has to provide, or it has to work when the link goes down, because there's more people doing things like media streaming within the home, and they want that to work even when the internet's gone away.
But I think that we tend to think today that a link that connects to our house will go up and down, like mine went down this morning. Right? As soon as it rains, my cable connection seems to but you know, maybe I'm overly optimistic that's not a sustainable position, right? It's not, because it's either going to be mandated by law and through regulation that you have a, you know, like telephone systems have been in the past where they were monopolies, or it'll just be through competition that this is the way in which we, you know, my friend has a more reliable service, and where I've got a choice, I'll just choose to use that, because it's becoming so important to the home that this will be a link that we will think like, you know, I don't have a backup generator for when the electricity goes down, because it's so reliable now. I think we are getting to a point where it will just be that. We will just assume it's there, and it will be really only in a big crisis. It's a big crisis I'm primarily concerned about either physically getting out or phoning someone with my 3G or 4G or by then 5G, you know, my phone, which doesn't depend on my own infrastructure at all. So yeah, I think actually that I would buy that it becomes this thing like my driveway. It's just something I assume is there, except for an earthquake.
Right. We don't get those.
Yeah.
No. So yeah, I mean, I don't have a strong view on it at the moment. I don't understand where the costs are now. I could easily believe that you'd be right that in 10 years' time or something, that's the kind of position we'll move to. I think when we do that, though, it will be important to make sure that you still have ways of getting the information out of the home to make the decisions appropriately. So some of the contextual information about what's trying to be done right now is important in making some of the decisions that have to be taken in controlling that device. So there's a thing at the moment in the UK where the government are going to said they were going to mandate that ISPs had to start doing quite a lot of detailed policing of home network use in terms of what websites were being accessed and so on. And doing that in a kind of blanket fashion seemed likely to always be pretty suboptimal. So we had a case, personally experienced this a few weeks ago, where visiting a relative and we wanted to book a table at the local pub to go for lunch with them. And my wife tried to look up the brewery website it was, where the details of contact the pub were, and she couldn't do that on her phone because she hadn't proved to Vodafone that she was over 18, and they wouldn't allow her to make that resolution access that website. And it's kind of, you know, well, firstly, I think that's pretty excessive to start with, but I could see that being reasonable in the case where it genuinely is somebody who is under 18, a child or something, but they didn't have the information at that point to make that decision appropriately. And the only way to get around that is for her to phone them up and say, give credit card details, because they really am over 18, it's okay, you can do this. And then that's a kind of blanket thing. And these kind of controls are too coarse-grained, I think, for making those decisions. So if the control does end up in the cloud, and I
so
it
doesn't mean that it's not customized. You can have it as customized as you want if it's in the cloud. I mean, that's only a position of.
But it's not static. What I mean is it's not statically customized. It's got to be kind of dynamically customized based on the other things in the context at the time.
Of course, no, I would agree. They would agree. Yeah, but it can be far more sophisticated in the cloud.
Yeah, possibly, and
so
you get lots of benefits maybe from doing
I mean,
things in a kind of community sense and having people collaborating to do this, looking at what other people around you are doing at the same time.
Yeah, right.
So yeah, I could believe that.
I mean, I would imagine that in that time frame, for starters, most people will actually have into the home a good 3G, 4G alternative, and so they will essentially have a backup path. And just as we tend not to think about how our 3G or 4G, I mean, most people probably have not the foggiest idea of where the nearest space station is, right, to where the home is. They don't even think about that as an infrastructure. The home network will probably look it will have the same feel, which is I am actually unaware of the existence of this, just as most people don't know where the fuse box is in the house. And there will be the same thing. I just don't even think about it. And so therefore it's something that is somebody else's problem, like reading my meter is now somebody else's problem.
I think in some ways it might be even more than that. So we've had as part of another project, we're looking at trying to do some work to help with digital exclusion problems in Nottingham. We got some questions into one of the surveys the council runs annually.
Just to be clear, so that's the lack of accessibility that some people have?
So the digitally excluded, in the UK apparently the last survey that I've seen the results of suggested that nationwide there's around 9 million people in the UK who've never used the internet. Never. And there are a bunch of different reasons as why that's the case, and I'm probably simplifying this too much, but I think it's roughly that people over a certain age don't see the point. And people under a certain age can't afford it. And these are the two big drivers, as I understand it.
They're the same 9 million that determined our presidential election.
One of the questions that went up on the survey, so one of the things is, this is often, so the information that's gathered there is often counted in terms of home broadband, fixed wireline broadband. And people are accessing the internet on smart devices and pay-as-you-go contract, SIM data plans and all this kind of stuff. It's not clear how much of that is included in that figure. And part of the reason it's not clear is that I think I can't remember if this was just answers in the survey or whether this was actually interview material that was done. But a bunch of people, I think relatively young people, 15 to 25 sort of range, I think. I can't remember the details. Where they're basically saying, oh yeah, no, I don't have internet access, I never use the internet. And I'm like, oh, okay, so how do you talk to your friends, how do you communicate with your friends? Or social media? Oh, I use Facebook.
Facebook, yeah. Right.
And it's like, I use Facebook, I don't use the internet.
Yeah.
And so it's this thing of the conception is about the service and the activity, not about the plumbing.
Right.
I just would like to ask a clarification. If you put everything in the cloud,
Oh yeah.
who is the owner of that piece of the cloud? The net service provider, or
That's a question of policy. It's not a question of technology, right? But a lot of these things, same thing with my Dropbox account today, who owns that may look different in 10 years. The technology may look the same, but the law may be different. So that's something that you will.
It is important. It is important.
It's an important policy question, and I think that we shouldn't be scared of technology for fear of policy. I think that we should separate the two and say you would allow the use of the technology, and then you would have a policy that would allow for it to make sense in that context. I mean, if we took that out, we wouldn't have the internet, we wouldn't have cell phones, because of the data that other people are holding on our behalf. We wouldn't have online shopping. We wouldn't have, there's all sorts of things that. So I think you have to keep hold those things separate.
Yeah, but it's easy when you give up control yourself. When you have control yourself, at least you control your local area.
You're not necessarily giving up control, right? You're not necessarily giving up, because someone can present to you the means to configure that however you agree as part of your service. So you can imagine the service which is, hey, I don't want to know anything about my network, completely manage it for me. Or you can imagine hey, I want to control my network, give me a web interface that will allow me to do that and give me the fine-grained control. That's not precluded by where that control is. I think it's just a question of where is more scalable, where is more likely to be cheaper for that management. Because I would guess that the vast majority of people just don't care about that kind of control. And hopefully in 10 or 15 years there's enough bandwidth going into the home. There's only a certain number of video channels I can be watching where I probably am not worrying too much about the use of it anyway. It's probably a access control that I'm more worried about. Who can be on.
The partly why people are not caring about control is that they're not aware of what is controlled and what is happening and what the flow.
Oh, I share your fear completely. In fact, I would put myself in the paranoid camp. But I think that we often make this mistake of confusing the technology with the policy. I mean, I think that the reason that Facebook is so annoying to so many people in terms of the data that's given out, in a sense, I would say it's not Facebook's problem is not a technology problem. It's the fact that legally that there is no, there's no attempt to push back against that boundary. I mean, in a sense, they're doing what they're allowed to do, and so long as there's a fear of having there are many attempts to have regulation, but as long as there isn't, the right way to do that is saying, actually, you can't do that. You can't require someone to give up that information, or that's better handled. It's not a question of technology. So I mean, I think I would agree with you in terms of fear. I would share the fear or the concern, but I think by saying therefore we shouldn't take that technology step is probably the wrong.
So I'd add to that by thinking that although it is important to consider them separately, in the sense to distinguish between them, I think that if you make them completely independent, you end up building things that don't permit the policies you want.
Oh, I would agree.
So
You've got to be able to think.
You
Yeah,
have to consider them
I
together.
definitely agree. Yeah. Good. Thank you very much, Richard.